specific in how you start each one of them. Today we're going to do it's funny, they call them simple. We have two styles. We got two styles to look at today, and I guess they are actually fairly simple. And then we will get into the fancier versions of all this stuff tomorrow. Good times. I know. As you guys know, I did something different this year. I flipped the order of this chapter. So obviously this first slide doesn't really pertain too much to where it was before. We talk about the idea of what are called simple rational functions. We've been working with rational functions. It's basically polynomial divided by polynomial, as you guys saw in the past few days. Multiplying, adding, subtracting, dividing, things like that. Quiz things. I should have everything. I've got like 4 of yours left to do, and then the 3 ladies that were out yesterday. I'm almost done. Believe it or not, they're not terrible. They're really not. There was a couple of dumb mistakes, and if you make a dumb mistake at one spot and you carry it through, it just gets dumber, if that makes any sense. But it was a dumb mistake at one part, but you mapped the rest of things, and that happened a lot. So these are another one of those styles of how it takes a little bit of time to go through it and figure out. Yes, sir. I should have those out this evening at some point, I'm guessing. Shouldn't be a big deal. I don't have much going on tonight now. Not like you really care. My schedule's pretty clear tonight. Just got to grill some pork chops. So now we've looked at these before. What we're gonna do here today. When we do take the test on this stuff next week, I do the graphs of these non-calculated. What I mean by that is the non-graphing calculator. Graphing calculator does too much for you here. You have to be able to use, you should be able to do a lot of this. It does too much, you're right. So one of the first things I like to look at with these rational functions is this. Y equals 1 over x. And when I'm looking at y equals 1 over x, we're going to talk about what can't x be? 0. X can't be 0. What you're doing here is you're finding the 0 of the denominator. We know that x can't equal 0 in this case because can you divide by 0? No. So when you've seen that before, what we've always had is we've put a vertical asymptote at a 0 of a denominator. So vertical asymptotes. An asymptote is an imaginary line that occurs where values don't exist. Yes, those are the diagonal asymptotes. Okay. This one is, you have what are called vertical asymptotes at zeros of denominators. And that always is a thing. Because think about when we solved equations, when you have an extraneous solution, the extraneous solution a lot of times was the value in the denominator that made the denominator 0. It was an answer, but it wasn't an answer. Okay. That's kind of the idea here. So if I'm going through this one here, I have a vertical asymptote at x equals 0. Because if it's x of 0, it won't work. Now, when we go back to the whole graphing idea, I always like to go back to the idea of picking values of x and just substituting them. So with our asymptote at 0, what I want to do is pick a couple numbers to the right, pick a couple numbers to the left. Let's do that, 1 and 2 on both sides. We'll start with that. If I put -1 in for x, what do I get for x? Or 1. -1. You get 1 divided by -1, and I get 1. If I put -2 in, what do I get? -1/2. Now, I know I didn't write this one down, but what would I get if I put -1/2 in? What's 1 divided by -1/2? -2. At half would be. So what happens here is that this is actually a curve that's approaching. This actually winds up being an asymptote here as well. We'll talk about how this one shows up in more so tomorrow, but for right now, it's just a generic idea. Because what I want you to do is think of this. Any number that gets larger and larger and larger to negative infinity, like negative 100, 1 over negative 100 is negative 100. If I do 1,000, 1 over negative 1,000, and so on and so on. I'm going to get infinitely closer and closer and closer to 0, but I'll never get there. Yeah, it's like, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you, I'm not touching you. Ah! All right, it's that idea. Same thing happens as it gets closer to 0. Divide by a half, divide by a 7, divide by 100, divide by 1,000, and so on and so on. It's going to get closer and closer to 0, but it won't be getting it. That's why we have exponents. You're not buying it.
Wait, why is this line curved?
Because one's divided. Trust me on this, okay? Not necessarily. Not necessarily. If I do the same thing with the positive values, it works the same way. Then all of a sudden, what does that look like? A hyperbola. Yep. Yep, that thing, yes. Very good. But you went like this, and then you went like that.
Yeah.
So I knew what you were talking about. It's the hyperbola on its side. These are technically called hyperbolas still. Now with these hyperbolas, we're not finding centers. We're not worried about vertices and foci and covertices and things like that. We're not worried about that. We're looking at them in terms of rational functions. Okay. Now today we're going to look at two types. One of the types that we look at, the first type we'll look at is this, and I'll write it on the whiteboard as well. We're going to have two types of rational functions we'll look at today. One of them looks like that. Y equals a over x minus h plus k. And what that function is going to allow us to do is that they're horizontal, vertical, very good. The line will have a vertical asymptote at x equals h and a horizontal asymptote at y equals k. If it was at 0, that means your h and k were both 0. It goes back to the idea of 1 over x. So what happens here is that we're taking the idea of y. Let's look at this. Y equals negative 2 over x plus 3, all subtract 1. And what I want to do is, as you know, a lot of times when we get into graph things, there's always multiple parts to the pieces. I like to label what parts I have. So I have an A, I have an H, I have a K. And I want to write it down. What is the value of A in this case? Negative 2. H, negative 3. Also notice negative 3 would make the denominator 0, wouldn't it? That's why that's the vertical asymptote. And then my k value is the minus 1. So the idea you were just talking about, Sarah, is why isn't it going through the origin anymore? If the origin was if it was x plus 0 minus 0, my h value would be 0. My k value would be 0. That's why that happens. And so we take those original asymptotes and we're moving them horizontally and vertically. All right. So we have a horizontal asymptote vertical asymptote at negative 3. and a horizontal asymptote, no, -1. The 0 of the denominator is always a vertical asymptote, and then the k value will always be our horizontal asymptote. Because remember, y equals a number is always horizontal. X equals a number is always vertical. Now, when we had our asymptote at 0, we picked two numbers to the right of it and two numbers to the left of it. Now that my asymptote's at -3, I'm going to pick two numbers to the right of it and two numbers to the left of it. I still do the same thing. We still pick the same type of values. We're just picking, instead of 1s and 2s, now I'm going to pick -2, -1, -4, -5. And a lot of times, this math is meant, if not, use a fraction. If I use -2 for x, what's -2 plus 3? 1. What's -2 divided by 1? What's -2 minus 1? So at -2, it's -3. Okay. Bless you. All right. Use -1. What's -1 plus 3? 2. What's -2 divided by 2? -1. What's -1 minus 1? When you know that these are all going to look like hyperbolas, they're going to be curving, bounding away from, or bounding towards their asymptotes. Asymptotes? Toes. All you need to have are 2 points, because now you know the general direction of the curve. You're going like this. Okay. Yep. Go to the other side. What's -4? What's -4 plus 3? 1. What's -2 divided by -1? 2. What's 2 minus 1? So at -4, we're at 1. What's -5 plus 3? What's -2 divided by -2? What's 1 minus 1? 0. So now you can see that's moving this way. And there's the curve. For each of these hyperbolas that we're going to talk about today in section 9.2, I want you to label your 2 asymptotes, horizontal and vertical asymptote, and then 2 points on either side. Usually, the next 2 numbers are all you need, and it'll help you find the direction. And now you got your comparison. -2, -3, -1, -2, -4 and 1, -5 and 0. Sir. Please do so. That's why we can't have this. Okay. Not terrible, is it?
No.
Looks a lot worse than it needs to be. All right, let's look at the other side. The other style is a little bit different. The other style is a little bit different. The other style is going to have 2 variables. A variable in the numerator, a variable in the denominator. your vertical asymptote is still going to be the 0. Oops, if I know how to spell the word 0. Of the denominator. And the horizontal asymptote is going to be at y equals the leading coefficients as a fraction. Now, when we have this, think of this as linear divided by linear. The degrees of both the numerator and the denominator are the same. X to the first divided by x to the first. Okay. Doesn't mean we can simplify those x's out. It happened a lot. Do that. The vertical asymptote would still just be the 0 denominator. So the denominator was 2x plus 3. That means the 0 would have been at negative 3 divided by 2. It's things that you've done. Just going to look a little different. Okay. For example, craft paper. Right? I'm not going to get into domain and range today. I want to just talk about the graphs. We'll expound upon domain and range. Sounded good, didn't it? We'll get into the domain and range stuff tomorrow as we start to talk a little bit more about the other types of graphs. So here we've got y equals, numerator is x plus 2, denominator is 2x minus 4. So first thing I always want to do is get my vertical asymptote. Is at the 0 of the denominator. What's wrong?
I don't know what happened.
What's that? Well, I know it's not me. I have water. Oh, you forgot that yesterday. So what's the 0 of my denominator? So I have vertical asymptote at x equals 2. What's that? Okay. So the horizontal asymptote for this stuff is going to be, since your degree in the numerator and the degree in the denominator are the same, they both have x to the first. Okay? The coefficient is going to be, or excuse me, the asymptote will be the leading term's coefficients as fractions. So the numerator has a leading term coefficient in front of the x of y. 1. The denominator has 2, which gives it a horizontal asymptote at a half. Vertical asymptote at 2, horizontal at 1/2. Which means, I'm going to kind of erase a little bit of that. I'm going to pick numbers that are to the left and to the right of 2, 3, 4, 1, and 0. Okay? And just like we've done, or I know you guys have all made tables. I like making tables that way I know where to sit and eat. That's okay. I'm not gonna lie. So if I use 0, what's 0 plus 1? 1. What? You're gonna drink more of that? What is 2 times 0? What's 0 minus 4? So now, at 0, it's negative 1/4. Oh no, how do I graph a negative 1/4? I am so afraid. It's close-ish. Okay? It's half of a half. It's close enough. So now you use 1. What's 1 plus 1? What's 2 times 1? What's 2 minus 4? So 2 divided by negative 2 is? Just with those 2 points, you now know the direction that it's going. Now I get to the other side. 3 plus 1 is 4. Divided by, well, 2 times 3 is 6. 6 minus 4 is 2. And 4 divided by 2 is 2. You use 4. 4 plus 1 is 5. 2 times 5 is 10. 10 minus 4 is 6. 6. Es posible. So 5/6 when it's 4. Now 5/6, can't see it very well. Is that more or less than 1? Less than 1. So it's a smidge less than 1, which is fine. So here-ish. Hey, look, it's still doing that. If I use 4, 4 plus 1 is 5. 2 times 5 is 10. 10 minus 4 is 6. Oh, I used 5 instead of 4. I didn't even realize I did that. I'm sorry. I'm sorry. Sorry about that. So this should have been 4. I didn't even realize I did that. Hey, it's still over there. I'm sorry, guys. I got the 5. Like, oh, x is 5. Oops. At least I plotted the right spot-ish. Let's move that up a bit. There you go. Now it's better. It would have been 5. It's use 4, you get 5 points. Because the numerator becomes 5, the denominator would be 8 minus 4, so you get 4. I accidentally used the 5 from the numerator and just substitute back, and I forgot that 5 does not equal 4. I didn't have my carrots yet, so I'm getting angry, I guess. It's my afternoon snack. I do too, but carrots are better than chips, like healthy-wise. Carrot chip. Oh, yes, I know what you're talking about. Yeah, those aren't bad, but here's the thing: those are so processed. No. There's some. It's like because we'll go through about 6 pounds of carrots a week. I'll take a bag. We'll buy them, peel them, cut them. My kids take carrots for snacks. My wife takes carrots for snacks. I take carrots for snacks. It's really fast to go through carrots. Anyway, let's do one more of each style. We'll call it a day. So let's see. Obviously, this is the style that we did first because there's only one variable. And as you go through this, remember, I'm always going to ask that you guys write down your horizontal, write down your vertical asymptotes, label them, and then plot them. But I ask that you make that little table chart to get your ordered pairs and plot them all through. So first thing here, where is your vertical asymptote? That one, good. Where's your horizontal? It's just that two. So your vertical is at x equals 1. Horizontal is at y equals 2. You don't want you using graph paper. You don't need it. Well, that means I don't have. You don't need to have the actual grids because I want you guys. The more practice you have at spatially pacing or writing things out, the easier trig graphing will become. Do you like the ocean?
No, not really. I got stung by a jellyfish.
Bad analogy. Do you like music? Music is broadcast and it's created via sound waves, right? Okay. The faster something takes to go through one oscillation, the higher the pitch, I believe, the slower the oscillation, the lower the pitch. How high up or how low it goes is volume, amplitude, if you will, and so on. That's just a sine wave. Oh, that's so close. Oh, I was so close on that one. Anyway, so my 2 points. 2 points on both sides. -1 and 0, 2 and 3. Can I do 0? I do 0. I can't use the 0 now. So if I use -1, -1 minus 1. 3 over -2 is -3 over 2. What is that? So what is that? -1.5?
Yes, it is.
-1.5 plus 2 is? Positive half. Yeah. 0 minus 1. 3 divided by -1. -3 plus 2. So here we have ours this way. What's up? Right. 2 minus 1. 1. 3 divided by 1. 3 divided by 1. What's 3 plus 1 now? All right, what's our then? What's 3 plus 2? I think you're right. Okay, now let's do 3 minus 1. 2. 3 divided by 2 is 1.5. 1.5 plus 2 is
4. 5.
1.5 erasers. Here are 2 more erasers. I was trying to help with the visual. What's that? I couldn't name a thing. There you go. That's what you're looking at. Take your time when you're substituting in values so you don't make dumb mistakes. Do your best bet. Or just use the fraction bar to kill it. Last one. Two x plus 2 over 3x plus 1. Where are they? Which asymptote is the negative 1/3? Vertical asymptote. Okay. So your vertical asymptote's at x equals negative 1/3. Horizontal asymptote then at 2/3 for y. No, I can't. No, literally, I will spell it wrong every single time. Oh, I don't care if you spell it wrong. It's not a spelling class. I think they're. I think it's ASMY. That's what I like. My kids do that now too. I see you. Seriously, this is the conversations in my house. I'm a 4th grader. This is what they do. Anyway, vertical asymptote, x equals negative 1/3. 2/3. I want to show this one because I know that sometimes we all tend to freak out when we see fractions. Since our asymptote, our vertical asymptote is really close to 0. Sometimes what happens, you get a weird, you'll get some weird numbers for either of the real close ones. In this case, 0 is really easy to work with, but as you start worrying about the other fractions, it can get kind of messy. So, if you use 0 for x, where's your y value? At 2. What's 2 times 1? 2. 2 plus 2. 3 times 1. 3 plus 1. 4 divided by 4. There's enough info here then to do this. Use -1. Use -1. You get -2 plus 2, which is 0. So at -1, it's going to have to equal 0 because the numerator is 0. At -2, -4. -4 plus 2 is -2. -6 and 1 would be -5. So that becomes 2/5. Positive, because negative divided by negative. Now, 2/5 in relation to the 2/3. It's close-ish. It's almost halfway. It's almost a half, but it's moving this direction. Okay. So it's going to do this. That's what I'm saying. Yes, ma'am. It doesn't, but it's usually the best. Your best bet is usually going to be the next two numbers on either side. You just could get a weird fraction. You just have to fix it. 4. 2 on each side. Nope. 2 on each side. Because I'll ask you to list the ordered pairs for your points. If you do the two to the right and two to the left of the asymptotes, it's the best way to do it. Because tomorrow we'll get into higher degree polynomials. We have like. Yep. I think I already posted the 4 problems. I'm gonna have you guys do 4 if I'm not mistaken. Do those 4, please. Tomorrow we'll get into. We should be able to get through the other 3 styles tomorrow. I don't see why we can't. See how fast we can get through them, but there's 3 others. Actually, was it 3 or 4? Well, it's one style that has like 4 rules, and it just depends. It's really easy to use once you see the rules. Then you'd be like, oh, well, yeah, so it won't be so bad. All right.